the radius is equal to 0.05 divided by 2 power 4. So this will be equal to 0.05 divided by 2 power 4 times 3 pi divided by 4 is equal to 306.796 times 10 to the power minus 9 meter to power 4. Okay. So we want to determine the LE. Okay. So if we look at our structure, excuse me. Okay, we'll look at our structure over here, right? At point A, moment is equal to 0, right? The cell is free to rotate. At point B, the moment is equal to 0. So both of them are pinned at both ends. Okay, pin at both ends. So you go back, you look at pin at both ends. Okay, so pin at both ends, LE is equal to L, right? So you look over here, pin at both ends, right? LE is equal to L. Okay, so LE is determine LE, so we know that LE based on both ends are pin. LE is equal to L, so this will be equal, the length is equal to 4, right? The length is equal to 4. Okay. So now with this information that we know, we can calculate our critical load. Okay. So our critical load is equal to pi squared. Young's modulus is equal to 200 times 10 to the power 9. I is 306.796 times 10 to the power minus 9. And our equivalent length is equal to 4 squared. Okay. So our critical load is shift by squared times by 200 power 9 times by 306.796 power minus 9 divided by 4 divided by 4 is equal to 37.849 times 10 to the power 3 Newton. So this is the critical load. Okay, that is the critical load that we are going to use. Okay. So before we go there, okay, before we do that, so we know that the load that is carried is 37.569. Then we also know that, okay, we also know this relationship where P critical is equal to the applied load P multiplied by FOS with a factor of safety, right? So from the factor of safety is equal to P critical over P, right? So we also know this relationship where we also know that P is equal to 2.732 AY, right? So our P critical over here, right, like I mentioned earlier, right, is equal to our safety of factor given is equal to 2. Okay, 2 multiplied by 2.732 AY, right? So this is equal to 2 times 2.732. So this is 5.464 AY. Okay. The load critical we calculate over here, right, is just based on how the structure is fixed. Okay. Then we have to relate to what is the load it can take over here. That's where the factor of safety comes in. Okay, so now we know the relationship where we can have 5.464 AY from this relationship over here, and this is equal to 37.849 times 10 to the power 3. Okay, so this P critical over here, this relationship is based on the Young's modulus, is based on the I, and is based on the what? L squared. Okay, whereas this over here, our P critical over here that we calculate is based on the loading. Loading from method of joints. Remember, we got these values through method of joints. So that's why AY now we calculate is equal to 57 or 37.849 power 3 divided by 5.464. So this is equal to 37.849 power 3 divided by 5.464 is equal to 669.27 Newton, or you divide by 9.81, 706.11 kilogram. So it's like close to 10 human beings on the beam. Okay. So we're going to next check based on critical stress, because we are given the yield strength of 703, and this is straightforward. Okay. So check based on critical stress. Okay. So stress critical is equal to, we know that the load that's going to take is 37.849 times 10 to the power 3 divided by the cross-sectional area, which is pi 0.025 squared. Okay. So 37.849 power 3 divided by pi divided by 0.025 is equal to 19.276 times 10 to the power 6 Pascal, which is less than the stress yield, which is equal to what? 7 0, I can't remember now. 703 megapascal. Okay. So this structure is a sound design, and the maximum load it can take is 706.11 kilogram. Okay, so this is example number 2.